Last class we were discuss about this 8051 microcontrollers. So we can continue the same topic. So we have discussed about the features. What are the different features of that 8051 microcontroller? So we know that it is a 4 KB on-chip program memory, and also it is having 128 bytes of on-chip data memory, 8 by 8 bit data bus, 16 bit address bus, 32 bit general purpose register, and also this 32 bit general purpose register, each register is having, 32 general purpose register. Actually, it is having 32 general purpose register, and each register is having the size 8 bit. Okay. Each register is having the size 8 bit, and two 16-bit timers, that is T0, T1, and 5 interrupts, that is 3 internal interrupts and 2 external interrupts, and 4 ports are the 4 IO ports for performing the IO communication. So these ports are 8-bit port. That means 8 lines are there for each port. So port 0, port 1, port 2, port 3. We will represent these ports are port 0, or sometimes it will represent P0, P1, P2, P3, like that. Total 32 IO lines are there. And also it is having a 16-bit program counter and a 16-bit pointer, 8-bit stack pointer resource. So these are we have last class. Okay. Now, next we can discuss the detailed architecture of this 8051 microcontroller. Okay, we know that it is a, that means it contains processor with the program memory, RAM, timers, serial port, input output port. Okay, or everything, interrupt controller, everything will be in a single IC. Okay, all these components will be in a single IC. So that is what we will call it as the microcontroller. Okay, so we can see the detailed architecture of this 8051 microcontroller. So this is the architecture diagram of this 8051 microcontroller. Okay, this is the architecture diagram. Here you can see that one ALU is the, okay, one ALU here, ALU is the, okay, ALU, temporary registers. These all together we will call it as the CPU. Okay, then RAM will be the, okay, EEPROM will be the, different ports are the, okay, port 0, port 1, port 0 is here, port 1 is here, port 2, okay, port 3. Total 4 IO ports are there. Our DPTR is here. Program counter is there. Program counter incrementer. Then there is a buffer. Then program address register, timing and control circuits. Okay, so it is connected to an oscillator. Okay, so these are the different components present in this 8051 microcontroller. Okay, components കണ്ടിട്ട് നിങ്ങൾ പഠിക്കേണ്ട, സെയിം തന്നെ, സിമ്പിൾ ആണ്. ഓക്കെ, സെയിം ഈ ഒരു കോമ്പോണൻസിന്റെ ഒരു elaborated version ആണ്. Okay. There is a CPU is here, interrupt controller is there, 4 kilobytes of ROM, 128 bytes of RAM, two timers, we will call it as timer 1, timer 0. Okay, timer 1 and timer 0. Circuit, bus controller, IO port, serial port. Okay, same components in a detailed view. Okay, അതാണ് ഇവിടെ നമുക്ക് കാണാൻ പോകുന്നത്. നമുക്ക് ഓരോ ബ്ലോക്ക് ആയിട്ട് പഠിക്കാം, അതായിരിക്കും എളുപ്പം. ഓക്കെ, ഫസ്റ്റ്, സോ നിങ്ങൾ കാണുന്നില്ലേ അല്ലേ? Okay, so here the first one is this block, ALU. You know what is ALU? and all. What is the duty of an ALU? ALU means it is an arithmetic and logical unit. That means whatever the operation, arithmetic and logical related operation, all these operations are performed in this ALU. Okay, so that is ALU. It is the arithmetic and logic unit present in this controller. Okay, here in this ALU, it will perform all the arithmetic and logic related operations. Okay, while performing this operation, it will reflect the status of the operation through this PSW. PSW means it is program status word. Okay, program status word. So what is the duty of a program status word is that it will reflect the status of the operation that is being performed in this ALU. Okay, so just like a flag, it is a flag register. You can call it like that. It's a flag register. That means it will uh, reflect or it will shows the current status of this execution. Okay, it will uh, program status word register. Okay, so perform all the arithmetic and logical related operations. Okay, while performing this operation, this PSW, that is program status word register, that will reflect the operation or it will shows the status of the operations. ഏത് operations ആണ് perform ചെയ്തത്? Okay, it will shows the status of the operation that is performing in this ALU. Okay, so actually how these ALUs are performing the operations? Okay, for performing this operation, it will take the values from these two temporary registers. Okay, so here you can see two temporary registers are there, T1, TMP1 and TMP2. Okay, so these are the temporary registers which are used to hold the temporary values. Okay, which are used to hold the temporary values for performing the arithmetic and logical operations. Okay, arithmetic and logical operations perform അതിന്റെ ടെമ്പററി ആയിട്ടുള്ള വാല്യൂസ് ഹോൾഡ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് it will use this ALU, okay, for holding the values, temporary values. Okay, so ALU will take the values from these two temporary register and it will perform the operations. Okay, ALU take the value from these two temporary register and it will perform this operation. After performing this operation, it will store the result, either it will be back to the accumulator. Okay, sometimes it will store the result into some other registers also. Okay, so that is how an operation is performing ALU. Okay, for performing the operations of an ALU, it will take the value from these two temporary registers. Okay, it will take the values from these two temporary registers and it will perform its operation. Okay, then after performing this operation, result may either stored in accumulator, okay, like this, through this bus. Okay, result may either stored in accumulator or it will be stored in some other register. Okay, depending upon the type of the instructions. Okay, depending upon the type of the instruction. And also, while performing this operation, this block, the PSW block, this is the program status word register. It shows the status of the operations. Okay, while performing the operation, if there is any carry generator or an overflow occur, whatever it is, okay, all these status will be reflected in this program status word register. Okay, so that is ALU, program status word register, TMP1, TMP2. These are the two temporary registers. Okay, then one more component here you can see that it is the accumulator. Okay, accumulator and all, you know that what is the function of an accumulator. Okay, accumulator will hold one of the operand in an instruction and also it will hold the result after performing this arithmetic operations. Okay, ഇതൊക്കെയാണ് അക്യുമുലേറ്ററിന്റെ ഫങ്ഷൻസ് അല്ലേ. ഒന്നുകിൽ ഇറ്റ് വിൽ ഹോൾഡ് ദ വൺ ഓഫ് ദ ഓപ്പറണ്ട്. ഓക്കെ, ഏതെങ്കിലും ഒരു ഓപ്പറണ്ട് the value it will be stored and also After performing the result, sometimes it will store the result into that accumulator. Okay, okay, we will call it as an A register. Okay, we will call it as A register, accumulator, or we will call it as A register. Okay, A register. So that is A register. Then another register you can see here, it is B register. Okay, actually these B registers are mainly used in case of multiplication and division operation performed in this ALU. Okay, നമ്മുടെ ഇതിൽ മൾട്ടിപ്ലിക്കേഷനും ഡിവിഷൻ ഓപ്പറേഷൻസ് ഒക്കെ പെർഫോം ചെയ്യുമ്പോഴാണ് മെയിൻ ആയിട്ട് ബി രജിസ്റ്ററിന്റെ യൂസ്. Okay, sometimes it will hold one of the operand, and also after performing the result, okay, if the higher order bits of this result will be stored in this B register. Okay, so you just remember that B register is mainly used to hold the operands of operands in case of multiplication and division operation, and also it will store the higher order result. Okay, after performing the arithmetic and logical operation, it will store the higher order byte value to this B register. Okay, so that is B register, and here it is accumulator. Okay, so ALU is ALUI, PSWI, then temporary register. These are holding the temporary value. Okay, for performing ALU. Okay, ALU operation. Then this is the accumulator, and this is the B register. Okay, so this is the B register. Then next block you can see here, it is the stack pointer. Okay, stack pointer. Stack pointer means the name itself, we know that it is used to point the top element in the stack. Okay, while performing any instructions, while performing any function call or whatever it is. Okay, so the stack pointer will hold the top element in the stack. Okay, it will hold the address of the top element in the stack. Okay, actually it is an 8-bit register. Okay, it will hold the address of the top element of the stack. Okay, so ALU is over PSW, temporary register, accumulator, and B register is the then stack pointer. Then another unit you can see here, it is interrupt or serial port and timer blocks. Okay, that means actually this block is associated with all the interrupt related operations, serial communication, and the timer communications. Timer, not communication, timer operations, timing or counting operations. Okay, all these operations are related to these blocks. Okay, so for performing this operation, here you can see different registers are there. Okay, different registers are there in this block. First one is PCON, the next one is SCON, then T mode register is there, TCON register is there. TCON, actually two timers are there. We studied that two timers are there. Then TCON and T2CON. Okay. Then TH0, TL0, TH1, TL1. Then there is an SBUF, then IE and IP. We can see what is the function of each register. Actually, PCON means actually it is related to power. Okay, that means our processor maybe sometimes it will be in ideal state or sometimes it will consume more power. Okay, for performing different operations. So all these related, all the power related information will be stored in this PCON register. Okay, ഇതിന്റെ ഡീറ്റെയിൽഡ് ആയിട്ട് നമുക്ക് രജിസ്റ്ററിനെ കുറിച്ച് ഡീറ്റെയിൽ ആയിട്ട് പഠിക്കാം. ഓക്കെ, ജസ്റ്റ് ഇപ്പോൾ ഓർത്ത് വെക്കാം, ഇറ്റ് ഈസ് PCON. ഓക്കെ, then SCON. SCON is actually it is associated with the serial communication. Okay, so in order to control these serial communications, we will use this SCON register. Okay, then T mode register is a timer mode register to control the mode of the timer. There are different modes of operations are there in the timer. Okay, in 8051 microcontroller, different modes of operations are there in T mode register. Okay, so all the modes related to information will be available in T mode register. And also, in order to control this timer operation, we are using this timer control register. Okay, we are using this timer control register TCON. These two timer control registers are used to control the timer operation. Okay, as I said that two timers are there. Okay, two timers are there. We will call it as timer 0 and timer 1. Okay, so these are the two timer registers. Timer 0, that will be represented as TH0 and TL0. Okay, TH0 and TL0. That means timer 0 lower order address and timer 0 higher order address. Actually, this timer is a 16-bit register. Okay, this timer is a 16-bit register. Okay, timer 0 is a 16-bit register. So TL0 will be represented by the lower order address of that timer 0, and TH0 is represented as the higher order address of that timer 0. Okay, the next one is TH1 and TL1. Okay, TH1 and TL1. Here TH1 and TL1 is the timer 1 register. Okay, it is the timer 1 register. Okay, in timer 1 register, TL1 represent the lower order bytes of the timer 1, and TH1 that will be represented by that is represented by higher order register. Okay, timer 1 register ആണ് അതിന്റെ lower order എന്ന് പറയുന്നത് that is TL1 ആണ്, higher order എന്ന് പറയുന്നത് TH1 ആണ്. That means actually it is a 16-bit register. Lower order 8 bits are TL1 and higher order 8 bits are TH1. Okay, then here you can see a register that is SBUF. Okay, actually this SBUF is used to hold the data that is while transferring in serial communication. Serial communicationന്റെ കേസിൽ നമ്മൾ അതിൻ്റെ ഡാറ്റാസ് ഒക്കെ ടെമ്പറലി നമ്മൾ ഹോൾഡ് ചെയ്യാൻ വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്ന ബഫർ ആണ് ദിസ് എസ് ബഫ്. Okay, S buffer is a buffer which is used to hold the data present in the serial communication. Okay, and also here you can see another two register IE and IP. Okay, so here IE represent the interrupt enable pin, and IP will be represent the interrupt priority. Okay, enable pin, that means interrupts enable ചെയ്യണോ disable ചെയ്യണോ എന്ന് ഡിസൈഡ് ചെയ്യുന്ന രജിസ്റ്റർ ആണ്. അതിൻ്റെ ഇൻഫർമേഷൻസ് ഒക്കെയാണ് IE രജിസ്റ്ററിൽ ഉണ്ടാവുക. ദെൻ IP രജിസ്റ്ററിൽ അതിൻ്റെ പ്രയോറിറ്റി ആയിരിക്കും. Okay, interrupt priority. So all these registers are together, we will call it as what? Interrupt serial port and terminal blocks. Okay, so here in this block, PCON register is there, it is related to power. SCON register is there, related to serial communication. Then T mode is there, T mode is related to the mode of the timer. Okay, that means for selecting the different modes in a timer, we will use this T mode register. The TCON is the register which is used to control the timer operations. Okay, which is used to control the timer operation, TCON register. Then these are the two timers, timer 0 and timer 1. So lower order address of the timer 0 is represented as TL0, and higher order of the address of higher order bytes are represented as TH0, and lower order bytes of that timer 1 is represented by TL1. The higher order byte, that means higher order 8 bit will be represented by using TH. Okay, so these are the different registers, okay, available in this block. Okay, so ALE is over. ALE is for performing arithmetic and logical operation. Okay, for getting the value, it will use two temporary register, TMP1, TMP2, and there is a PSW. It shows the status of the operation. Okay, it is a flag register. Then accumulator is the accumulator. Accumulator means it is a register which hold the one of the operand, or it will store the result after performing any arithmetic or logical operations. Okay, then B register is there. Here in 8051, B registers are mainly used in case of multiplication operation and all. Okay, and stack pointer is used to point the top element in the stack. Okay, then different registers, another different special registers are the PCON. Okay, special function register we can call like that. Okay, PCON, SCON, TMOD, TCON, and TH0, TL0, that is timer 0, TH1 and TL1, that is timer 1. Then SBUF, serial buffer is there. Then IE, interrupt enable, and IP, interrupt priority. Okay, ഇത്രയാണ് ആ ബ്ലോക്കുകൾ. Then next we can see the blocks outside this bus. Okay, so this is the timing and the control unit. Actually, this is used for generating the control signals. Okay, so for that it will use an oscillator to provide the clock input. Okay, so for that it will use this oscillator uh, to provide the clock input, and this timing and control unit will generate the corresponding control signal. Okay, PSEN signal is there, ALE is there, EA bar is there, RST is there. Okay, so we can see നമുക്ക് ഇതിന്റെ ഓരോ പിന്നിന്റെയും ഫങ്ഷൻസ് ഒക്കെ ഡിഫറെന്റ് ആയിട്ട് പഠിക്കാം. ഇപ്പോൾ ജസ്റ്റ് ഓർത്ത് വെക്കുക, this timing and control units are used to generate the timing and control signal. Okay, so timing and control units are used to generate the timing and control signal from the value that is received in this instruction register. Okay, so what is the duty of an instruction register? Instruction register is nothing but it will hold the instruction that is fetched from the program memory. Okay, that means whenever there is an instruction, or instruction നിങ്ങൾക്ക് execute ചെയ്യണമെന്നുണ്ടെങ്കിൽ first it has to fetch from the program memory. Okay, so ആ പ്രോഗ്രാം മെമ്മറിയിൽ നിന്ന് ഫെച്ച് ചെയ്തിരിക്കുന്ന ഇൻസ്ട്രക്ഷൻ സ്റ്റോർ ചെയ്യുന്ന രജിസ്റ്റർ ആണ്, ദാറ്റ് ഈസ് വാട്ട് ദ ഇൻസ്ട്രക്ഷൻ രജിസ്റ്റർ. ഓക്കെ, ദെൻ ടൈമിംഗ് ആൻഡ് കൺട്രോൾ യൂണിറ്റ്. Timing and control unit is used to generate the timing and control signal. Okay, timing and control unit is used to generate the timing and control signal, and instruction register is which is used to hold the instruction that is fetched from the program memory. Okay, program memory fetch ചെയ്തിരിക്കുന്ന instruction hold ചെയ്യാൻ വേണ്ടിയിട്ട് we are using this instruction register. Okay, then another block is, you can see here, it is data pointer. Okay, data pointer is actually it is a 16-bit register. Okay, data pointer is a 16-bit register. One main duty of this data pointer is to fetch the data or programs from the external memories. Okay, whenever you are using an external memory in this microprocessor, then for fetching the data from this external memory, it will use this data pointer. Okay, so what is the duty of the data pointer? Data pointer is used to hold the address of the external memory. Okay, data pointer is used to hold the address of an external memory. That means by using that address, it can fetch the values or data from the external memory to the processor for executing its operations. Okay, so that is what a data pointer. Okay, data pointer. Data pointer is used to fetch the values from external memory to the processor. That means our controller. Okay. Then here you can see another block, that is program counter is there. Okay, program counter. This program counter actually it is used to hold the address of the next instruction that is going to be executed. We all know that what is program counter in case of 8086. The same function here it is performing. Okay, so it is used to hold the address of the next instruction that is to be executed. Okay, while fetching an instruction, the program counter will automatically increment its value and point to the next instruction. Okay, so that is the program counter incrementer. Okay, so that is what the program counter incrementer. Okay, so what is program counter? Program counter is a register which will point the top address the next instructions. Okay, that means program counter is used to point the next instruction is to be executed. That means it will hold the address of the next instruction. Okay, it will hold the address of the next instruction. There is a buffer. Okay, while receiving these data. Okay, first all these data will be stored in this buffer. Okay, then only it will be transferred to the different registers and also accumulator for performing all these operations. Okay, so മെമ്മറിയിൽ നിന്ന് ഡാറ്റ ഫെച്ച് ചെയ്ത് കഴിഞ്ഞാൽ ഫസ്റ്റ് ഇറ്റ് വിൽ ബി സ്റ്റോർഡ് ഇൻ ദ ബഫർ. Okay, first it will be stored into the buffer. Then through this buffer only it will be transferred to the different registers and accumulator for performing operation. Okay, so these are the different blocks here. Data pointer. Data pointer means it is a register. It is a 16-bit register which is used to point the external memory address. Okay, data pointer is used to point the external memory address. And program counter is the program counter is used to point the next instructions. Okay, that is going to be executed. Okay, so for while fetching any instruction, the program counter value will be automatically increment. Okay, it will be automatically increment. Then there is a buffer is there. Okay, that will be hold the data that is coming from the memory. മെമ്മറിയിൽ നിന്ന് വരുന്ന ഡാറ്റ ഒരു ബഫറിൽ കൂടിയാണ് നമ്മുടെ ഇന്റേണൽ രജിസ്റ്റേഴ്സിലോട്ടൊക്കെ മൂവ് ചെയ്യുക. ഓക്കെ, സോ ദിസ് ഈസ് ഈ ബ്ലോക്ക് ആയി. ഓക്കെ, then next we can see the different memories. Okay, here you can see a ROM or EEPROM. Okay, here we can see a RAM. Okay, so these are the two memories, two internal memories present in this 8051 microcontroller. Okay, two internal memories. RAM memory is there and ROM memory is there. ROM memory or PROM memories are, we will call it as a program. That means it will hold the instructions that is going to be executed. Okay, നമ്മുടെ പ്രോഗ്രാം സ്റ്റോർ ചെയ്യാൻ വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്ന കോഡ് സ്റ്റോർ ചെയ്യാൻ വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്ന മെമ്മറിയാണ് റാം ഓർ EEPROM memory. Okay, so this is the internal RAM memory. Okay, then നമുക്ക് അതിന്റെ അഡ്രസ് കിട്ടാൻ വേണ്ടിയിട്ടാണ് പ്രോഗ്രാം അഡ്രസ് രജിസ്റ്റർ യൂസ് ചെയ്യുന്നത്. Okay, to fetch the program from the RAM memory. Okay, so ROM memory, we will use program address register. Okay, program address register fetch ചെയ്യാൻ വേണ്ടിയിട്ട് from the instruction from the RAM memory. Okay, fetch ചെയ്യാൻ വേണ്ടിയിട്ടാണ് program address register യൂസ് ചെയ്യുന്നത്. The RAM memory actually it is a data memory. Okay, it is a data memory. Data memory means what? It will store the data values. Okay, it will store the data in the 8051 microcontroller. So RAM ilana nammude data store cheya. To get the address of the RAM, you will use a register called RAM address register. Okay, so you will use a register called RAM address register. Okay, so a RAM is there, that is data memory, and the ROM, it is a program memory. Okay, then next we can see the different ports associated with these 8051 microcontroller. Okay, different ports present in the 8051 microcontroller. Port means it is a connection between the external IO device to the microcontroller. Okay, here in case of 8051 microcontroller. Okay, in case of 8051 microcontroller, there are four IO ports are there. Okay, there are four IO ports are there. First one is port 0. Okay, port 0. So this is the port 0 driver and corresponding latch is here. Latch and all, you know that what is a latch. It will store the value that is received from this port. Okay, this pin. Okay, ഈ പിന്നെ കൂടെ വരുന്ന വാല്യൂസ് ഈ പോർട്ടിലെ ലാച്ചിൽ സ്റ്റോർ ചെയ്യും. സിമിലർലി ദിസ് ഈസ് പോർട്ട് 2. ഓക്കെ, സോ port 2 and corresponding port 2 latch. Okay, similarly, here you can see this is port 1. Okay, then corresponding latch is here. Then this is port 3 and the corresponding latch is here. This is the port, sorry, this is port 3 driver and corresponding latch, port 1 driver, corresponding latch. As I said that each port is having the size what 8 bit. Each port is having the size 8 bit. 8 bit means it is having 8 lines are there. 8 bidirectional lines are there. 8 bidirectional IO lines are there. Okay, so port 0 line we will represent it as what P0.0, P0.1, P0.2, P0.3 up to P0.7. Okay, so this is the pins. These are the pins associated with the port 0. Okay, similarly, port 1 pins are there. We will represent it as P1.0, P1.1, P1.2, P1.3 up to P1.7. Okay, P1.1, P1.2, P1.3, P1.4 up to P1.7. That we will represent the different pins in the port 1. Okay. Then next one is port 3, that we will represent as P3.1, P3. Sorry, P3.0, P3.1, P3.2 up to P3.7. Okay, so 8 ports are there. Okay, so this is the architecture. Okay, just നമ്മൾ ബ്ലോക്കിനെ കുറിച്ചേ പറഞ്ഞുള്ളൂ. ഇതിനെക്കുറിച്ച് ഡീറ്റെയിൽ ആയിട്ട് നമുക്ക് പറയാം. ജസ്റ്റ് നിങ്ങൾ ഇത്രയും ബ്ലോക്കുകൾ ഉണ്ടെന്ന് ഓർത്ത് വെക്കുക ഇതിൽ. ഓക്കെ, ഇത്രയും ആർക്കിടെക്ചർ നേരത്തെ പഠിച്ച അതേ സിമ്പിൾ ബ്ലോക്ക് തന്നെ കുറച്ചും കൂടെ എലാബറേറ്റ് ചെയ്തിട്ടുള്ള ബ്ലോക്കാണ് ഇവിടെ അല്ലേ. എന്തൊക്കെയുണ്ട് ഇതിൽ? ALU is the ALU എന്ന് പറഞ്ഞാൽ കൂടുതൽ ഡിസ്കസ് ചെയ്യേണ്ട ആവശ്യമില്ല അല്ലേ. ALU ഇറ്റ്സ് ആൻ അരിത്തമാറ്റിക് ആൻഡ് ലോജിക്കൽ അല്ലേ. സോ ഫോർ പെർഫോമിംഗ് ദിസ് ALU ഓപ്പറേഷൻ ഈ രണ്ട് ടെമ്പററി രജിസ്റ്ററിലുള്ള വാല്യൂസ് ആണ് യൂസ് ചെയ്യുക ഫോർ പെർഫോമിംഗ് the ALU operation. ALU operation. Then after performing the operation, the result will be stored either in some of the registers or accumulator or the B register. Okay, depending upon the instructions. Instruction base ചെയ്തിട്ട് നമുക്ക് ALU result ചിലപ്പോൾ it will be stored in the accumulator or sometimes it will be stored in the B registers. Okay, depending upon the instruction, it will store the value to different register. Okay, then while performing this operation, the status of the operation will be reflected in this program status word register. Okay, actually it is an 8-bit register. നമുക്ക് അതിന്റെ ഡീറ്റെയിൽഡ് ആയിട്ട് പഠിക്കാം. ജസ്റ്റ് ഓർത്ത് നോക്കുക എന്താണ് this ALU is the status of the ALU operations are reflected or it will shows the status of the operation. Okay, PSW. Then accumulator register is the one of the operand while performing any instruction. One of the operand will be in the accumulator register or sometimes the result will be stored in the accumulator after performing the operation. Okay, then B register is also that is generally in case of multiplication and division operation we will use B registers and all. Okay, then stack pointer is there. It is used to point the top element in the stack. Then different functional registers are the PCON, SCON, TMOD, TCON, TCON, TH0, TL0, TH1, TL1, SPUF, IE, IP. PCON is related to power, SCON is related to serial communication, TMOD and the TCON. These are the two timer register. Okay, two timer register. TMOD register is used for controlling the mode and the TCON register is used to control the timer operations. Okay, two TCON registers are there. Then this is the timer 0, TL0 and TH0 and this is timer 1, TL1 and TH1. Okay, then SBUF is the IE is the IP is the SBUF serial buffer, IE interrupt enable and IP interrupt priority. Okay, so അതിൻ്റെയൊക്കെ ഡീറ്റെയിൽ ആയിട്ട് നമുക്ക് പഠിക്കാം. ജസ്റ്റ് ഇത്രയൊക്കെ ബ്ലോക്ക് ഉണ്ട് ഇതിലൊന്ന് ഓർത്ത് വെക്കാം. Okay, then DPTR useful to get the data from the external memory. Program counter used to point to the next instructions. Okay, program counter incrementary is the buffer used to hold the data that are coming from the memory. Memory നിന്ന് വരുന്ന values hold ചെയ്യാൻ വേണ്ടിയിട്ട്. Then program address register, it is useful in case of program memory. Program memory address program address register. Okay. Similarly, RAM memory, RAM address memory. So ROM memory and program memory, RAM memory is our data memory. Okay. Then timing and control unit is it is used to generate the timing and control signal. It is used to generate the timing and control signal. And instruction register is which is used to hold the instructions that are coming from the memory. Program memory instruction hold instruction register. Oscillator is used to provide the clock input. Okay, then different ports are the port 0, port 0, port 1, port 2, and port 3. All these ports are 8-bit port. Okay. അപ്പോൾ ഇതിന്റെ ഡീറ്റെയിൽ ആയിട്ട് നമുക്ക് ഓരോ ബ്ലോക്കുകളും ഡീറ്റെയിൽ ആയിട്ട് പഠിക്കാനുണ്ട്. അപ്പോൾ ജസ്റ്റ് ഇതൊന്ന് ഓർത്ത് വെക്കാം. അപ്പോൾ ഈ ബ്ലോക്കുകളുണ്ട്. ബ്ലോക്കുകളുടെ ഓരോന്നിനും ജസ്റ്റ് എന്താണ് ഫംഗ്ഷൻ നമ്മുടെ ഓർത്ത് വെക്കാം. ഓക്കെ. ബാക്കി നമുക്ക് അടുത്ത ക്ലാസ്സിൽ എടുക്കാം. നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം. ആശിഷ്, അഭിനവ്, അഭിഷേക്, ആദിത്യ, ഐശ്വര്യ, അഖിൽ സി വി, അഖിൽ കെ, അമൽ സുരേന്ദ്രൻ, ആമിന, അരുണിമ, അല്ല അനൈന, അനൈന, അനിരുദ്ധ്, അൻഷിത, അൻഷിത, അനൂജ, അനുപമ, ആരോമൽ, അർപ്പിത്, അരുൺദത്ത്, അശ്വിൻ, അസ്ന അബ്ദുൽ ലത്തീഫ്, റംഷാദ, ഋതു, ജെറീഷ്, ഖദീജ, ലിഖിത്, ലിയാന, മിഥുൻ, നാസിഫ്, റാസി, മിനാജ്, നിഹാൽ, സാലിഹ്, ഷഫീഖ്, നബീൽ, നന്ദ, നന്ദിത, നിവേദ്യ, പ്രിൻസ്, നൂഹ, ഋഷികേഷ്, റസ്വിൻ, രോഹിത്, ഋത്തിക്. ഓക്കെ, ഋത്തിക്, രോഹിത്, സഫീർ, സങ്കീർത്തനം. സാരം. സേജൽ. ഷബിൻ. സെവിൻ. സിഷാജ്. തനുശ്രീ. തേജ. തുളസി. വൈഷ്ണവി. വിഷ്ണു. വൈഷ്ണവ്. യാദവ്. അമൽ. ഓക്കെ, നമുക്ക് അടുത്ത ക്ലാസ്. താങ്ക് യു.